Particle starts from rest and moves in a straight line with uniform acceleration. It passes 3 points A, B, and C. Now, so what happens is, does it start from rest? Okay, so we call this point the starting point, S. Then it passes 3 points. So it passes the point A, then it passes B, and then it passes C. Okay, now B to C is shorter than A to B, so I might just move B over slightly. Okay. Now, would you all agree that's 105 and that is 63? You cool with this? Now, it takes 6 seconds to travel from A to B, so a time frame of 6, and 2 seconds to go from B to C. Find the distance of A from its starting position. So its U value is 0 here. What would be its initial speed at A? Would it be 0 or something bigger? Why is it bigger? Because it's accelerating all this time. So here's the trick. The trick is when you're doing what's called an interval question, where you have one vehicle and it travels through signposts or whatnot, you always do the following. You'll do A to B, and then your next data will be A to C. Never do like in between parts like B to C. B to C will result in a nightmare that you can't get out of. Okay, so has everybody got the key point? Start to first point, start to end. Okay, that's how you do this. Now here we go. Let's start off with A to B. What's your U value? Do we know it? Call it U. What's your V value? Do we know it? Don't worry about it. What's your A value? A. What's your S value? Yeah. What's your T value? 6. Grand. Not much info there, is there? Okay. Next one. We'll go for A to C. What's your U value? It's also U. Why is it U? Because A, B, and AC have the same start point. Is that okay? That's why we do that, because those two variables are now the same. V we don't care about. Acceleration is A. Our S value is 160. T value 8. I'd like us to use the equation S equals UT plus a half AT squared. I want us to form two simultaneous equations, and I want you to solve said simultaneous equation. Now, I'm going to shrink this down a little bit. And then, okay, for the red data, it's going to be 105 equals UT, which is going to be 6U. The half AT squared, T squared is going to be 36. So it's going to be a half A times 6 squared, which is 18. A. Yeah, just leave it like that. And then for the blue one, it's going to be 168 equals 8U, and then a half A times 6, half A times 8 squared, which is 32A. We code that. Now, see that second equation, the blue one? Would everything divide by 8? That'd be, it would, wouldn't it? So what you reckon it is then? 21 U and what's that, 4A? Yeah. Okay. Now what I'm going to do with the blue equation now is I'm going to multiply it by minus 6. So I'm going to multiply the blue equation by minus 6. And what I should get is minus 126 minus 6U minus 24A. Is that right? Whoa, no. Oh yeah, we're grand. Okay. So is everybody happy with that? Then add downwards and what happens? Minus 21 equals minus 6a. 6a equals 21. A equals 3.5. And then once you do the simultaneous equation, you can then find the u value. So I shouldn't have rubbed out that. That one's the good one actually. What was the one we had earlier, the blue equation, when we divided it across by a? What did we get again? 21, wasn't it? U add 4a was 21. That's it. Okay, and then replace a with, so u plus 14 is 21, therefore u is 7. Okay. Now the next question is, how far is S from A? So does anybody know what we can do for S to A? What's the starting point? What's the velocity at S? What's the V value? No, it ends at A, so your V value is actually the U value of it at A. So what can we say then? 7. Acceleration? 3.5, yeah? And then what are we after then? We're after S, aren't we? And we could use, we don't need to find T. Could we do phi squared equals u squared plus 2as? And then say that if you rearrange the formula, it's phi squared minus u squared equals 2as. And you just grab that 2a and you put it underneath, and we could get the answer directly that way, couldn't we? So what's phi squared? 7 squared minus 0 squared all over 2 times 3.5 equals S. S is 7 meters. So yeah, only covered 7 meters from S to A.